Hello, you're welcome to my channel. I want to say good day to all my subscribers. I want to believe you are doing very, very fine. Yes, the long-awaited volumetric analysis for this year Waec practical is what I'm going to be doing. And I'll be giving out some salient informations. I'll be doing that in 2 segments. I will give students some informations, very, very, very vital information. And please, I persuade you, follow those instructions strictly. Another instructions I'll be giving will be to my fellow chemists or chemistry teacher, as the case may be. I'm still going to be giving some tips about how the practical is going to look like. I've had a lot of questions on my DM. Okay, so many people have reached to me as regard this year Waec. But I will make some clarifications in this video. That's the reason why I need you to watch this video carefully and beautifully. Please watch it very carefully so that you don't do the wrong thing on the day of the exam. So welcome once again to Chemistry Hangout, and I'll be making clarifications to this year volumetric analysis for Waec. If you are a new subscriber to this channel, click on the subscribe button and put on the notification bell so that when I upload any video, you are going to be aware. So welcome once again. Now, let me quickly start by giving some information as regards the preparation to my fellow chemistry teachers. A lot of people has reached out to me, and as regards the iodine not dissolving in the potassium iodide, a whole lot of problem encountered when they were preparing it. But you don't need to actually bother yourself, because if you have adhered strictly to the instructions, there is nothing to worry about. Waec examiners that gave us the instructions actually know what they are doing. So we don't want to assume that they don't know what they are doing. No, that would be very wrong on our part. Our own is to get the reagents ready using the specification they gave us. Okay? After using the specification they gave us, titrate and let us see what our average titer is going to look like. So we don't need to get ourselves confused, because if you look at the confidential reports they gave us, let me quickly start with my fellow chemistry teachers or chemistry instructors. If you look at the instruction they gave us, you see they gave us 6.0 gram of potassium iodide. That's what they gave us in the instruction. They gave us 24.82 gram of sodium thiosulfate. That's what they gave us. And they gave us 25.4 gram of iodine. This was what they gave us in the instruction, that we should prepare the iodine solution, by dissolving 24.4 gram of iodine in 6.0 gram of potassium iodide. Now, the reason why they are asking us to dissolve it in potassium iodide is because iodine is not that soluble in water. So when you dissolve iodine in water, it's not going to be soluble. And the reason for adding the potassium iodide is to aid the solubility of iodine. Now look at this. Theoretically, this can never dissolve 25.4 gram of iodine. Some people reached out to me that they crushed it, they heated it, it's not still dissolving. 6.0 gram of potassium iodide will never, theoretically, will never dissolve all 25.4 gram of iodine. How? Because the equation of reaction for this is that we have potassium iodide plus iodine. You get that now? Potassium iodide plus iodine. That's what we are dissolving. And what will be formed is potassium triiodide. I hope we are getting something now. I just want to show something here. Now, if you look at this, the atomic mass of iodine is 127 times 2. That gives us 254. And this is 39. Atomic mass of potassium is 39 plus this, that's 127. Okay, so 127 plus 39, this will give me 9 plus this 16. Okay, this will be 5 plus 1, that will be 6. So that's 166. Can we see that? So theoretically, if for this reaction we will be needing 166 gram of potassium iodide to dissolve 254 gram of iodine. Can you see that? theoretically, we are going to be needing 166 grams of potassium iodide to dissolve completely this very particular mass, which is 254. But in the instruction they gave us 6.0 grams of iodide. So if 166 grams will dissolve 254, then 6.0 grams will dissolve X of this. So I'll be having 6.0 times 254 over 166. So let's see that. Let's quickly see that. 6.0 times 254 divide 166. So I'll be having 9.18 gram of iodine. Meaning this 6.0 gram of potassium iodide they gave us will only dissolve 9.18 gram. Can we see that? Which is even, and the one they even gave us in the instruction, look at it, they gave us 25.4, which is around triple of what is supposed to dissolve. So definitely all the iodine cannot dissolve if you have used 6.0 gram of potassium iodide. I hope that is clear. So out of the 25.4 they gave us, out of the 25.4 gram of iodine, minusing 9.18, we are going to be having around 16.2 gram that will not dissolve. We're going to be having around 16.2 gram that will not dissolve. Do we get that now? So very, very important, all the iodine will not dissolve in the potassium iodide solution. What you are just to do is just use the iodine solution, you are the one that has dissolved, use it for the titration, and that's all. I hope that is clear. So theoretically, the only one that can dissolve, if you use 6.0 gram, will be 9.18 gram of iodine. Can you see that now? So, and that will be around, if I'm looking for the molar now, that will be 9.1, no, just looking for the concentration now, 9.18 divide 254. So I'll be having around 0.035 molar. 0.035 molar, of this iodine at the end of the day for the instruction that we are giving in the end. So very, very important, we don't need to bother ourselves, okay? We don't need to bother ourselves. If we are going by this specification, all the iodine will never dissolve. The one that will dissolve, the mass of iodine that will dissolve, if we are using this theoretically, will be this, okay? So we can have less than, but the maximum it can dissolve, the maximum gram it can dissolve, will not transfer 8 gram. So definitely we are going to be left with a whole lot of iodine in the flask, in the volumetric flask. There will be a whole lot of iodine there that will not dissolve because this potassium iodide cannot dissolve all the iodine that is being given. So that's not a problem. Let's just carry out the preparation dutifully and let's titrate. So, and that is all. And to the students now, please endeavor to read the question. A whole lot of students has asked me, sir, which one will be in the burette? Is it iodine that will be in the burette? Is it iodine that will be in the burette, sodium thiosulfate in the conical flask, or sodium thiosulfate in the conical flask, iodine is the burette? Now, the answer is this. You can have iodine in the burette while you are pipetting sodium thiosulfate, yes. And you can have sodium thiosulfate in the burette while you are pipetting iodine. I'm going to do the two so that we can see what it is like. But if you are going to have iodine in the burette, if you are going to have iodine in the burette, it means that you need to increase the concentration of your potassium iodide. If not, you might not have a reaction. I will demonstrate it. You're going to see. So we are not saying this is the exact question. This is a guide. To students, this is a guide of how the question is going to look like. Read the question dutifully. Why I can tell you iodine will be in the burette? We don't know. It might be. Because we have iodimetry, we have iodometry. They are two different things. Maybe other subsequent video will differentiate between the two of them. We have iodimetry, we have iodometry. Do you get that now? So iodine can be in the burette, while sodium thiosulfate in the conical flask, or sodium thiosulfate in the burette, iodine in the conical flask. Okay, but we are predicting that they will ask us that we should have sodium thiosulfate in the burette. That is a prediction, might not be true. So on that day of the exam, read the question, know the one that is supposed to be in the burette. If you see my sample question, I said, here's the solution. Put A in the burette. You can see, they will instruct you of the one to be in the burette. So on that day, read the question very carefully and know the one they want to ask you to put in the burette. They might ask you to acidify. They might ask you to, the question can come in so many ways. But your own is read the question and do what they actually ask you accordingly. So I hope that information helps. So very quickly, I'll go to the titration now. Very quickly, I'll go to the titration. So we don't need to get ourselves worried. And very important for volumetric analysis for students. Let me quickly say this: when you are answering volumetric analysis question, one thing that is sure is that the concentration of one of the solutions will be given directly or indirectly. So the concentration you are giving or the information you are giving will now make you to look for an unknown. Because you are working with two solutions, okay? You are working with two solutions. So definitely one will be given and they will ask you to look for another. So anyone that is being given, the calculation is still very, very similar. That's why I want you to pay attention. The calculation looks very, very similar. Either they gave you the concentration of iodine, look for sodium thiosulfate, or they gave you the question for thiosulfate, look for iodine. You are still saying the same thing because it is still similar. One standard solution must be given, which means the concentration of one will be known. Then you look for the concentration of the one that is not known. Or the concentration of the other will be given and you look for this one. The question can come either way. So we don't need to get ourselves worried at all. So I hope we watch this video to the end so that you can see a lot of things that I will demonstrate. So this is my prediction. Okay, this is a prediction based on what they are giving us. This is just a prediction of what to expect. But if you know how to do this, no matter how the question comes, it will still rally around all these things. You should be able to do it on the day of the exam. So I have A is the solution obtained by dissolving 12.2 grams of an impure sample of iodine molecule in an aqueous solution of potassium iodide and made up to 1 kg. Okay. B is the solution containing 24.82 grams of sodium thiosulfate pentahydrate. Put A into the burette. Look at the instruction. Put A into the burette. And which one is A? Put A into the burette. So I put B because that's my prediction. Put B into the burette and titrate against 20 or 25 centimeter cube portion of A. Right? Can you see that now? That's my own prediction. That sodium thiosulfate will be in the burette. That's my prediction. So put B, which is sodium thiosulfate, into the burette and titrate against 20.0 centimeter cube or 25.0 centimeter cube portion of A. So we are titrating against iodine solution. So that means I'm pipetting iodine solution. So read the question. The one in the burette will be, they will tell you the one in the burette. They will tell you the one in the burette. So use that solution as indicator. Repeat the titration to obtain concordant values. Tabulate your reagents. So let's see. This is my solution. This is my sodium thiosulfate. So let me put it in the burette now. Sodium thiosulfate in the burette. Let's see. This is my sodium thiosulfate in the burette. Very important. Okay. This sodium thiosulfate now in the burette. Let me have some so that I can add to the 0 mark. I hope you are following. So you don't need to bother yourself. It's a very simple experiment. Just follow instructions. That's it. Just follow instructions. Follow instructions. So very, very quick. Let's have our table now. Let's have our burette readings now. Okay? Burette readings. Centimeter cube. Okay. I'll be doing about 2 thereabout so that I don't waste all my solution. Graph. This is first centimeter cube. This is second centimeter cube also. So let's have this the final. Please tabulate your readings very well. This is the final readings, okay? This is the initial readings. This is the initial readings. This is the initial readings. First, second. This is the initial readings. So complete the table, very important. And don't forget, use starch solution as indicator. So very important. Let them know the indicator you are using. That's starch indicator. Starch indicator. That's the indicator we are using. So let's start our titration. Very, very important. I remove my funnel before starting the titration. So this is my iodine solution already prepared. So let me pipette. So let me pipette this. I need 25 of these. So that it's free of bubbles. Okay? So I'm using 25 centimeter tube. Very good. Into my conical flask. Very important. Okay. So what happened? I will not add my starch indicator before titrating. The reason is because your starch forms a complex with iodine. So starch has the ability to lock up iodine. So if you add your starch, it will affect your readings because it will lock up the iodine. So you will need more sodium thiosulfate to actually react with the iodine. So that's the reason why you titrate first until you see a light yellow. When you see a light yellow, it indicates that the reaction is close to completion. Then you now add your starch indicator. So let's go. Look at the solution we started with. So let's see. You can see that now. Can you see? Let's have a bit. You can see. This is a light yellow. Then let's have our starch indicator now. I'm using about 2 drops, 1 and 2. So you can see a blue-black, indicating that you still have iodine here. So let's see. Now gently, please, when you are titrating this, gently, in drops, gently, in drops, very important. Until you have a colorless solution. Gently, you can see, you see that, colorless. So let's have our readings now. I have around 8.70. I have 8.70 as my rough. I have 8.70 as my rough. Can we see that? I have 8.70 as my rough now. That's the first titer. Don't forget the initial readings started from 0.00. So I have 0.00 here. And don't forget our volume, the volume of pipette. The volume of pipette has to be recorded very, very important. That's 25 centimeter cube. That's my volume of pipette. I hope you are following. So that's my rough. That's my rough titration. Let me put this away. Put this away very quickly and just start with the second titration because you know this is around 8.70, so I can still start from here. So which means my initial now. But if you are refilling, I've done that in a whole lot of my videos. If you are refilling, the initial will be 0.00. But now I'm not refilling, I'm starting from that place. So my initial here will be 8.70. Why I start again. I don't want to wash this with water because if you still wash with water, it will still affect. There is no way you still have some, some water molecules there, and it will affect when you put the iodine. Do you get that now? So I'm not washing with water. That's why I'm just trying to swirl the conical flask so that everything leaves. Okay, I'm pipetting again, 25 centimeter cube. Another 25 centimeter cube of iodine. Okay. Running into my conical flask while I begin titration. Okay, let's see again. That's another one. Let's see. See how it goes. See, when I say light yellow, I had my starch indicator, just 2 drops, 1. I'm using 2. So you have a blue black now, and I titrate. Gently, please. Take your time to do it, so that our average titer will be very accurate. Gently, please, gently. Can you see that? Okay. Here I have 17.60. 17.60. Here I have 17.60. So here I'll be having volume of, some people will write acid, it's not acid, they are using sodium thiosulfate. So volume of sodium thiosulfate used. Okay? Here I have 8.70, just subtracting. Let's subtract this one. See? 17.60 minus 8.70. That's 8.90. This 8.97. Can we see that now? So we can decide to start from that 17 again, because you have a whole lot of thiosulfate in the bread. So I can have 17 here, 0.60. 17, so that one will be 17.60. So let's see what we are going to have. Okay, so let's titrate again. Let me dispose this. Okay, try to swirl so that we have everything. So this will be the last titration before the calculation. Okay, let's have another 25. Another 25. Okay. I hope you are getting it now. So we don't have anything to worry about. Just obey the instructions given on that day and just do your titration and you are fine. Okay? This is the second one. Let's move. Go again. And you say light yellow. Okay, let me add a bit so that yellow will be obvious. Okay, so let me have 2 drops again. 1, 2. So let's go. Thank you. Thank you. Gently, please, gently, so that we can get an accurate endpoint. See, I'm just adding it, you can see. You can see that now. So let's go 26.30. You can see. Bring it very close so that you can see. can see 26.30. So we have 26.30. Okay, so let's do the subtraction now. 26.30, 26.30 minus 17.60. That's giving me, let me see. Sorry, bring it very close. Let's see. 26.235. 26.50. That's what I'm saying here. Sorry, I'm taking the upper minuscule. 26.50. Okay, so let me see. 26.50 minus 17.60. Okay, I have 8.9 also. 6.50. Let me be sure of this. Please bring it very close. Okay, bring the camera closer so that we can see. You can see that 26.50. You can see. Very good. So 26.50. You have to be very careful when you are taking the readings from the board. I take the lower meniscus. So the first one, try and take the lower meniscus so that you don't get yourself confused. Okay, so this is it now. Then we can now have our average volume now. My average volume of sodium thiosulfate used. Okay? You know, sometimes you can even use your rough. Sometimes if the rough is closer, if it's closer to your titrations, yes. We don't use the rough if the rough is very far. But all like this one, I'm still taking the 2. But if the rough is very closer to your the titrations you have done, we can take the rough if it's closer. But I'm just trying to take this 2. I can still take the 3 because it's a bit closer to my titers, but I'm taking this 2 because this one is more perfect. So I can have 8.9 plus 8.90 divided by 2. Okay, so I have my average volume of sodium thiosulfate used is 8.90. You can see that now from the titrations. 8.90 centimeters. Okay, let's now go to the question proper. That's the titration, very simple. So we can do that day. It's a very simple titration. So you now said from the concentration of B in mole per dmq. Concentration of B in mole per dmq. If you have been watching my videos, you should at least know how to do all some of these things by now, because I've done a whole lot of volumetric analysis videos. So concentration of B in mole per dmq, okay? Concentration of iodine molecule in A in mole per dmq. So let's start now. Concentration of B, 1. Concentration of B in mole per dmq. So what's the concentration of B in mole per dmq? They gave us the mass of B, you can see. We know that formula, we're giving that formula over and over again. Where we have our mole is equal to mass over molar mass, okay? We can only use this formula to calculate mole if the 2 parameters are present. And here you have your mass, you can calculate the molar mass of this, so we can use this. So let's calculate the molar mass. The molar mass of Na2S2O3.5A2. That gives us 23 times 2 plus 32 times 2 plus 16 times 3 plus 5 into bracket 1 times 2 plus 16. Trying to calculate the molar mass of it. So this gives us 46 plus 64 plus 48 plus 5 into bracket. This 2 plus 16. That will be 18. Okay, so 46 plus 64 plus 48 plus 18 times 5, that should be 90. So plus 90. That gives us 248. So molar mass is 248 grams. Please, the units are very, very important per mole. And they are giving us the mass to be 24.82. So our mole becomes 24.82 over 248. So our mole becomes 24.82 divide 248. That's giving us 0.100 mole DNP. That's sorted. Number 1 is sorted. Now they said concentration of iodine molecule in A in mole per DNP. Now look at the question. They said A is a solution obtained by dissolving 12.2 grams of an impure sample. Look at that. So what they gave here is an impure sample, but here they are asking to calculate the concentration of the pure one, because they didn't say calculate the concentration of impure A. No, what they gave in the question is impure, but what they are telling you here, there is no any impure here, meaning they are asking to calculate the concentration of the pure one, not impure. So if you use this value, what you will be getting is the impure iodine. So you are not to use this very particular mass, because this is the mass for the impure. Okay, so how do you get the concentration of the pure one? Then we go to our titration formula. You know, we are familiar with that. Using number 2 now, using our CAVA over CB, V equals NA over NB. I hope that is clear. So our A, we are making this our A, iodine, don't forget. We are making our iodine A, and we are making our sodium thiosulfate B. So what is the concentration of A, which is iodine? That's what we are looking for, the pure one. This is the impure, we are looking for the pure one. So CA, we don't know it. That's what we are looking for. Plus volume of A. What is the volume of A I calculated? That's 25. Recorded already. 25 over concentration of B. What's the concentration of B? You have gotten that already. That's 0.100 times the volume of B. That's our titer value. The average titer we have got it. That's 8.90. Is equal to, go to the equation of reaction it has been given. What is the number of moles of iodine? Here, you look at it. That's one molecule of one mole of iodine molecule. That's what we have here, 1 mole. So that's 1 over what of sodium thiosulfate? 2. So we cross multiply. So from here we are going to have CA to be equal to 0.100 times 8.90 over 25 times 2. So our CA becomes, let's have our calculator, 0.100 times 8.90 divide 50. That's giving us around 0.0, that's giving us around 0.0178 mole. This is the concentration of the pure one now. Please pay attention to that. Of the pure one now. Then I said, definitely, if question comes and you see impure sample, the probability they will be asking to calculate percentage purity is high. Yes, there is a form of impure in the question, then definitely they can ask you to calculate percentage purity. So how do we calculate percentage purity? The formula pure over impure times 100 over 1. So we need the pure acid now. What is the mass of the pure acid? We have gotten the concentration in mole per DMP. So once you get this now, please let all your calculations be in your booklet, so that you don't just go and extract one value from somewhere that the examiner did not know. So we want to calculate concentration of pure iodine now. Iodine molecule. Concentration of pure. So we have this, mole is equal to mass over molar mass. Okay? And we know that molar mass of iodine, they have given us the atomic mass 127, so that 127 times 2, and that will be 254 grams per mole. Please, the units are very, very important. So we are calculating the mass. Now this is the mole, so we cross multiply. We have mass is equal to mole times molar mass. So from here, mass will be equal to, what is the mole? 0.0178 times 254. So let's see what the mass is going to look like. Times 254. That will be, the mass here is 4.521 gram. You can see that now. 4.521 gram. That's the mass of the pure. Okay, let's see the mass of the impure now. Let me do it here. The mass of the impure iodine. How do we get that? They are giving us the mass in the question. Guys, you can see that now. They are giving us the mass in the question, which is what? 12.2 gram. Can we see that? So, want to calculate the percentage purity now. So, percentage purity will be pure. What is the pure? 4.521 over impure 12.2 times 100 over 1. Can we see that now? So let's go. 4.2 divide 12.2 times 100. So we have 37.05. Let's just say 37.1. So percentage purity is 37.1. Please put your percent. Because it said percentage purity. And that's all. That's all. So mass of the impure, we have gotten that. And that's it. And you know, I just added this. Sometimes they might ask you number of moles. Some students used to find that very particular, that very particular part difficult. So when they ask you to look for number of moles, the formula for number of moles, please note that today and just add that in your mind that when you are calculating number of moles, the formula is concentration times volume. But in most times, because the mole they gave you, because we want to convert to DMP, we now have to divide by 1,000. Do you get that now? Because what they gave us is centimeter cube. So that's the reason why if you look at this place now, it's a centimeter cube. You can see it's a centimeter cube. So it's because I want to convert. That's why I'm dividing by 1,000. But the formula for number of moles is concentration times volume. So you can be asked to calculate number of moles of any of the solutions. Just know it's concentration times volume over 1,000. Because most times this unit, this one, look at it, is a centimeter cube. So if it's a centimeter cube, you divide by 1,000. So they're now saying number of moles in the average titer. What is the number of moles in the average titer? And what is the average titer? 8.90 centimeter cube. So what is the number of moles now? I'll do that here. So number of moles in the average titer. Number of moles in the average titer. So that will be what? Concentration times volume. Because this is a centimeter cube, that's why I'm dividing by 1,000. So what is the concentration? What is the concentration of this very particular sodium thiosulfate? We have gotten that that's 0.100 times what is the volume of sodium thiosulfate? 8.90. So it's a centimeter cube, that's why I'm dividing by 1,000. So the number of moles will equal to, so let's see, 0.100 times 8.90 divide 1,000, and that's giving us 0.00089 moles. 0.00089 moles. That's what it's giving us. So you can just calculate number of moles of anyone, number of moles of the pure iodine. If they say number of moles of the pure iodine, that's this concentration. What's the concentration of the pure one? This is it times the volume. What's the volume? 25 divided by 1,000. So, but if they specify number of moles in 500 centimeter cube, you get that now. Let's take for example they specify number of moles in 500 centimeter cube of the average titer. So they are not asking you to use this one again because they have specified the volume in the question. But this one, yes, a number of moles in the average titer. What's our average titer? 8.90. And that's all. That's all. So very, very important. So just go through all this. If you are giving this, and that's the reason why I said sometimes they'll give you all the information for this, you look for this, it's still the same thing. Sometimes they give you the information for this, you look for this, you are still saying the same thing. So just watch this video carefully and adhere to the instruction on that day. Adhere to the instruction on that day. Very, very important. Not the one they ask you to put in the burette, not the one they ask you to put in the pipette, and do justice to those questions. Now, let me quickly round up with this. For some people that have been calling me that, sir, can you have iodine in the burette? Can you have sodium thiosulfate in the pipette? This is it. What they gave us for Waec. Waec gave us a specification to prepare, which is this. Now, I want to reverse it now for you to see it yourself. Because I've been seeing a whole lot of people I've been seeing a whole lot of people with different perspective. Everybody is entitled to his own perspective. But what I have prepared and what I am seeing without adding anything, let's look at it so that we understand. You know, sodium thiosulfate was in the burette before, and I pipetted this. So let me have this now. I don't have enough this again. If you put the iodine in this, you will not have a reaction. Yes, I don't have enough iodine again. I would have done that. You will not have it. You will finish everything here and it will not change. Okay, because it is simple. Because the solution of this, the potassium iodide that is there is very small. So the concentration of iodine, I have done that when I started the video, is small. So it might not actually have a solution. But if you increase the concentration, that's what I'll be doing now. This one now is a different one. I have increased the concentration of potassium iodide here. I have increased it. So if you increase it, this is what you will have, which is not supposed to be. You are not supposed to increase it because you are supposed to go with the specification Waec gave. I hope that is clear. You are supposed to go with the specification Waec gave. For this one, this is not the specification. I have increased the concentration of potassium iodide here. Okay, so let's see what happens. If you are going by this, let's see what happens. Let's see what happens. I've increased this. This is not the specification. I'm just trying to show you something. Okay? Trying to show us something so that we see it. So don't increase the concentration. That's my advice. Okay? I will advise that we don't increase the concentration. We just go by the specification Waec gave and just see how the question is going to unveil on that day. So let me pipette this now. No, I'm adding this one now. So let me pipette this. Let me pipette this. Let me pipette this. This is another reaction anyway. I'm just trying to show you. So that we can see it. If you increase the concentration, then I can add my iodine solution because this is sodium thiosulfate. So I can add my starch indicator just to 1 and 2. And let's see what it's going to look like. So if I titrate it against this, I might likely have a reaction. Can you see that? I hope you are seeing something. It was a colorless solution before. Let's continue so that you see. So that I'll be sure. Can you see? We have a blue-black indicating that all the sodium thiosulfate here has been used up, and what you have here now is the iodine solution and the starch. You can see from colorless to your blue-black solution. But this is not what Waec asks us to do. I hope that is clear. This is not what Waec asks us to do because I've increased the concentration of potassium iodide here, and that's why you're having a reaction like this. But if I use the one Waec gave me, putting sodium thiosulfate here, okay, putting iodine here rather, if I use the specification Waec gave me, using iodine here and titrating it against sodium thiosulfate, it will not give, without adding anything, it won't give a, you will finish all the one in the burette and you don't have a change in color. And that's the reason why we are predicting that based on what they are giving us, it should be sodium thiosulfate in the burette, sodium thiosulfate in the burette, and you are pipetting iodine. But please read the question on that day. I am not saying this is the exact question they are going to be seeing. This is just a guide of how the question is likely to be. Do you get that? This is a 50%, prediction of how the question should look like based on what they gave us. So you don't need to get yourself confused. The one I have done, that's how it is done. If you are putting sodium thiosulfate here and you are titrating it against iodine, that's what I have done in the practical video. And likely questions are what I have solved. So please, if you have any question, you can use the comment box, okay? And I want to appreciate Mrs. Ebube Precious. I want to appreciate her. She's one of my subscribers. Thank you so much. She's one of the person that supported this very particular practical, you know, because most of these things we do, some of these reagents are very, very cost, and that's the reason why it took me time before I could be able to do this practical, because you know, I need to order for those reagents. We don't have them, I need to order. So it was part of the subscriber that reached out to me and sent some funds to support this very practical. So Mrs. Ebube Precious, thank you so much. I appreciate it. God bless you tremendously. And if you feel like you want to always support our practicals too, you can reach out to me on my line. It's on the channel. You can reach out to me on my phone number. You have it on the channel. You can request for it in the comment section. I love you guys. I wish you success. My fellow chemistry teachers, please, let's just prepare the solutions and I'll wait what the question is going to be. But you don't need to panic. Let's just go by the specifications they give us. They actually know what they are doing, okay? They actually know what they are doing. So let's see what is going to happen with the question on that day. Let's have the reagent prepared. That's what I've told other fellow chemistry teachers that have called me. Make sure the iodine solution is prepared. Make sure the sodium thiosulfate is prepared. So in the instruction on that day, anything they ask us to add, we are going to add, but make sure that we have dutifully prepared according to specification what they ask us to prepare: the iodine, the sodium thiosulfate, the potassium iodine. Please stick strictly, I beg you, stick strictly to those specifications. Don't change them. Don't change them. Stick to them so that we don't actually get wrong readings on that day. Thank you very much. God bless you. If you are a new subscriber, please click on the subscribe button and put on the notification bell so that you'll be informed when I upload video. For my subscribers, Waec students worldwide, anywhere you're watching me in the world, you know, you can benefit from this. But for my Nigerian students and some other students in other countries that are taking this exam, I wish you success. Please study this practical very well, and in your own lecture time, try to actually do something to boost your confidence for the exam. I wish you success. Thank you so much. God bless you.